This is going to break a little bit of the immersion of the video, but it is actually New Year's Eve, and I am down here getting the TPU Air ready to go. Here's my dryer, and there's the filament. So I'm really sorry to SirayaTech. I told them I had this done a little bit ago, or I was going to work on it a little bit ago, but because of how busy my December went, I didn't get to work on it. But I thought this was going to be really funny to talk about the fact that I'm starting it on midnight. But this is the first time I've ever opened this. I just filmed the portion where I do the frog video, and I am so excited. This is like the perfect green. I think this is what the Crocs are made out of. So, oh my gosh, I'm so excited. I'm also very tired and I'm very sick. I'm just powering through to make these shoes because I've wanted to play with these for 2 months because this came in end of October, I think. All right, so into the dryer this goes, and I'm going to see you when this starts printing.
Well, like Past Me said, Happy New Year! I wanted to start off 2026 on the right note and top my previous biggest video. Last year, I ended on the high note of my 3D printed Crocs. I had a blast making these, but left that video off on a bit of a note where I wanted to move towards improving. That is where today's video comes in. At 3D Printopia, I started chatting with SirayaTech and they were blown away with my shoes and wanted to help me make more. I pitched a specific shoe to them, and they loved the idea and gave me the go-ahead. So today I bring you the next evolution in my 3D printed shoe series. To begin, let's discuss some of the areas I left off on from the previous video. I would definitely recommend watching that one first, but for those of you that haven't, or if you need a refresher, here's a summary. The two aspects I wanted to fix was shoe support and shoe flexibility. Flexibility is a little bit more obvious. Crocs are a more rigid shoe when compared to something like, let's say, a tennis shoe. This makes them really great for casual settings and especially sandy terrains, but I don't often find myself in these settings. For something like 3D Printopia or Anime NYC, walking around the city or a convention hall wasn't the most comfortable experience. This leads into the second issue, support. Crocs are made with thinner walls, which work great for traditional injection molding, but when translated to 3D printing, this doesn't really allow for much infill generation, leading to an overall weaker support on the foot and thus the feeling of walking straight on the ground. The way I described this in those videos is that the shoes feel like they were bottoming out, and I could feel the ground underneath me much more than with traditionally made shoes. One way to fix this would be through adding more walls or increasing infill, but that would also decrease flexibility. You might now see why these two issues are very closely related. The way this could be fixed is somehow with a lighter material, but also still more rigid. Well, that's where TPU Air comes in.
Okay, so here we are in front of a lot of stuff. So let me go through and kind of explain why I have everything here and how it contributes to the video. So over here on the left, I have the first tests that I did with the TPU Air. So what I did first was I printed out a bunch of these squares. What this let me do was test out all the properties of this filament. This filament is very different than any other TPU I've ever used. I've used 95 and 90A TPU in my previous Croc video. This filament is a variable shore hardness filament, which means depending on the temperature you print it at is a different, let's call it springiness. Ace, can you explain a little bit more?
I'd be happy to. Shore hardness is a measure of how elastic a plastic is. For shorthand, I call this the springiness amount. On screen now is a scale of shore hardness with a few examples to demonstrate. You can see that as the number decreases, that being the number in front of the letter, the springiness amount increases. Now, since this material has a variable shore hardness, it means that depending on the temperature it's printed at, the shore hardness will change. To demonstrate this, let's go back to Ace in the workshop.
So now that you know a little bit more about variable shore hardness, let me explain why I tested it here. So these tests right here are at a lower temperature. These were at about 240, 250, and then I eventually landed on 260. Now the reason that I started with 240 was because the temperature range is 235 to 270. Now that is a very large range, and so I just rounded up to 240 because then I could test in increments of 10. The reason that I tested these different shore hardnesses is because of what happened with my Crocs. And so what I wanted to find here was the perfect amount of hardness for the shoes that I ended up going with. So here is the first test at 240. You can see I hadn't dialed in flow yet, and right here is our first main thing to note when using this TPU Air. So you can see here that the bottom of the piece is actually ripped and torn. That is not because it under extruded, that is because I was not prepared for how much it would stick to the build plate. So a little bit of an aside, but this will be important, is that TPU Air really likes to stick to the build plate. This is from the final shoe that I ended up printing. It is just so stuck to the build plate. You have to really try to rip it off. And in fact, it will stick better to the build plate sometimes than it will to itself, which will lead to the shoe ripping in half, which is what happened with one of my first attempts here at getting the shoe. I believe this was the right shoe, and it tore in half before it tore off the build plate, and so I had to reprint it. The thing that you want to do to fix how much it sticks to the build plate is you want to use a little bit of glue on the plate. I know for people that normally print with PLA, using glue to make it stick less to the build plate sounds counterintuitive, but trust me when I say the glue in the case of TPU actually acts as an interface layer between the print and the bed, and so it is much easier to peel off. So that's why I have this glue stick here. So you will see a lot of these samples have this issue where the bottom is like ripped off. You can see here, this one had the exact same issue. It almost looks like I took a bite out of it. I might have gotten a little too hungry. Here is the next set of samples. These are all at 250 degrees Celsius. And these were not bad. I liked them. However, I started to run into a big issue with under extrusion. So this takes me to the next thing that you need to know when printing TPU Air. TPU Air is so flexible that it will often have trouble getting through whatever setup you have from the actual roll of filament to the print head.
Okay, so now I think is a great time to discuss the printer I used and how I used it to print out everything in this video. Originally, I had planned on using my Bamboo A1 to print these shoes, as the print volume is a bit bigger than my K1, so it would allow me to resize the shoes to better fit my foot. I quickly moved away from this plan when I tried to test shore hardness, as each test square failed to extrude properly. I've seen examples of TPU Air working on the A1, but I wanted something way more reliable. In the end, I went back to old reliable, my Creality K1. Anyway, back to the explanation.
As you'll notice on the inside, currently it is unmodified, and I was able to print the Bowden tube setup unmodified and still get successful prints. But it took a little bit of trial and error to get there. These ones all ended with this section where they were under extruded. And at first I thought it was because the filament was jamming, but that's not entirely the case. You can see this little plug here at the bottom of the filament. Now what happens is, because this filament is so flexible, when the roll is spinning on whatever spool holder you have, if there's too much friction on the inner core right here, when this tries to pull into the extruder, it'll slip. And if it slips just a little bit, this plug will form and it won't be able to extrude anymore. So here I am with my K1. It's now on and ready to go. So I'm going to show you how I would recommend fixing a blockage and unloading and loading the filament, because it is a little bit different than the stock setup. So first off, what I'd recommend is, normally when I cut filament, I cut it at a little bit of an angle so that it gives like a piercing angle for the filament to actually like pass through the gears. However, I would actually recommend a blunt end on this filament because it's so flexible. Cutting it at that angle will actually just give it more force to just flex. So I found in all of my testing that the best was a blunt, straight angle for the cut of the filament. So once the filament gets to around here, I take this lock off of the PTFE tube. I push down on this and pull out the PTFE tube. Now what I do is I push the filament the rest of the way through, so it's poking out just enough for me to grab. Then I go over here to the extruder and I push it to the unlock mode. Now I take the filament and I pull it just a little bit. Extra slack is good because it will let you then push this into place. Now, as you're going through, if you get any resistance, like right now you see it's bending, I would recommend you twist the filament in your hand in a circular shape back and forth to actually get it in until you get to a place where you're getting a lot of resistance. That means it's all the way in. Then lock it to test that you actually got it down in and didn't just get more resistance at the top. Give it a light tug and you'll notice that as I pull it, it flexes. It is ready to go and all in. Now I just put the PTFE tube back, again with a little bit of finessing, lock it into place, put the plastic lock nut in, and then you're ready to go. Now on the screen, I would recommend something hot, so like a little bit hotter than 240. I did 250 for all of my testing, and then you hit extrude. Now in a second, it's gonna come out of there. Okay, now that the filament has extruded, if I'm going to print it, I wait for it to cool down till it's below 200, so like around 190. And then that's when I will clean off this nozzle right here, just with a little tool. Be careful that you don't crush the nozzle, as when it's hot, it's a little bit more malleable. If this does not work and you are not seeing any filament come through during the extrude scenario, I would take a scrap piece of PLA and run it through at around 250 to 260. That will then give the extruder something to bite onto, so the rough filament of the PLA, and it will be able to push it through the hot end and you will get that block purged through. Then you can go back and repeat the steps that I showed you to load the flexible filament or the TPU Air, and then you should be ready to go. This does lead me to talk about how I got the filament to actually run, and so I will go to the back of the printer and I will talk about that now. So the stock filament holder that the K1 comes with has too much friction with these cardboard spools for this to be able to print. What I first tried was the poly dryer. So the poly dryer has bearings that can rotate and it gives you generally not a lot of friction. And I can show the setup that I had where it was going directly from the dry box into the printer. This was just too much friction. Ironically enough, not from the PTFE tube, but actually from the rollers. This filament is crazy flexible. I've never seen a filament this flexible, and you really need no friction at all from the roll to the printer. So what I had to end up doing was printing it directly from the side of the printer
not enclosed and not drying. It was just out, because if I had it on any type of roller, it just was too much friction and it could not print. This is why a lot of people that print SirayaTech TPU Air or any other types of TPU Air generally print with the filament on top. I didn't want to modify my printer like that just for this project. And also I felt like that added weight was going to add extra ringing to the print. So I wanted a different solution. Those of you that have subscribed for a while might know that I actually have an SV08. If you know of the SV08, you know that the stock filament spool holder that it comes with is really good. Almost too good. The big complaint that people have of this spool holder is that it actually has too little friction, and spools will actually unwind while they're printing because it just spins and spins and spins and spins really easily. Knowing that this is the same size as the stock spool holder, I actually just swapped this in. And so this is actually how I was able to get the full print going, was by using the SV08's spool holder. So for those of you that don't have an SV08 and aren't in this very niche use case that I am in, I actually have on one of my old videos the 3D printed roller bearing spool holder from my Ender 3 restoration video, and I will link that right up here. So that one uses the same roller bearing idea and should help reduce the friction. Now that one isn't a drop-in replacement, so you will need to find a way to attach it. Now what this did bring up, and that's the next point, is drying and printing from a dry box. So let's talk drying. Here are two frogs. One is, these are both before I did my calibration as seen in my calibration video. Could you tell me which of these was printed outside and which of these was printed inside of the dry box? Give you a little second to look at them. Okay, lock in your answer by putting it in the comments, and then I will tell you the answer. Okay, that should be enough time. You're all wrong. These are both printed outside of a dry box. So all of these samples were printed with the dry box, where I just manually reduced the friction by pushing the filament by hand and giving it some slack so that it could print. Everything on this side was printed outside of a dry box. So I cannot notice a large change in how much stringing there is between prints. To be fair, I'm going to show, like I said, these two. This one is inside of a dry box and this one is outside. So I really don't see a large difference in the amount of stringing between these. I don't think that keeping the filament inside of a dry box really affected the print, as long as you dry it beforehand. Every time I printed each shoe, I dried the filament for 12 hours, and specifically on the poly dryer, it has these settings that you can see here. And I printed each one on the TPU setting, so like right here, for 12 hours. Now, SirayaTech only recommends around 6 hours of drying. I like to go overnight because it is perfectly doable for me to just turn on the dryer and leave it overnight, and then in the morning start printing. Okay, so now that we're kind of through how I got the filament to print, now I want to look at calibration. Here, you'll notice that aside from the fact that it under extruded, which again is a friction issue, you'll notice that there's these ridges in a repeating pattern. And at first, I thought this was something to do with the under extrusion. However, I noticed that ringing was still happening on some of these models that I printed out. You can see it very faintly in this first test piece that I printed. But the reason for that layering is actually because it's over extruding. And what happens is, as the filament over extrudes, we assume that it's a squished oval, but when it over extrudes, it'll actually dovetail over the sides and form almost like a shape, like a weird crushed heart.
And that's how we get this really gross layering. What I did was I honed in the flow. The parameters that SirayaTech advises for 260 degrees on the nozzle is a flow of 0.58. So these tests right here, this was the macro and then this was the micro. I ran it at the 0.58 number that SirayaTech advised. I found that that number was actually even still a little bit high, and I knocked it down to just a little bit lower. I think I ended up with about 0.55 once my tests were done. The other thing I did want to share, because I thought it was really cool, is I did not calibrate pressure advance, because pressure advance might monkey with this filament since it is so flexible. So that calibration method I did not use. I went straight for max volumetric flow because the speed of printing TPU is very important. So here is a sample that I tested. It is much smaller than the average ones. Looking at this, you can see it doesn't really fail across the whole thing. And so I was like, geez, this is a max flow of 5. So this can flow really, really fast for some reason. While I don't know the underlying reason as to why it's able to flow faster, my guess would be because it is much less dense when compared to other TPUs. But this is the second one, and I started at 5 and then worked my way all the way up to 10. And you can see right there towards the top it starts to fail. So I went conservative and I kept it at 5, even though I know I could technically go faster. I am not someone who will compromise quality for speed. And so if you're a speed demon and you need to get this stuff printed out really fast, go for those higher speeds if your printer can handle it. But I wanted it to be more reliable, so I went a little bit slower. The final thing that I want to talk about is color calibration. So the original whaleberries, as shown on MakerWorld by the original designer, use the H2D. Now I don't own an H2D, and originally I was going to use the Bamboo A1, but I already discussed why I did not use that. And so my plan is that I was going to start the print in one color, in this case green, and then I had a pause at layer where I was going to manually switch the color from green to white in this case. What I was hoping is it would give a gradient where it would go from green to white or white to green. So this plan did not work of mine because I did not allow for enough to be purged, because I was trying to hold that green in there as long as possible so that it would purge through, kind of like my color calibration. In order to get the actual next color to load properly, I had to purge so much material that it ended up just going right from one color to the next. While this could be used as a cool technique if you're trying to do a color swap at layer, I was hoping to get a gradient, and that's not what I saw here. So I ended up ditching the multicolor idea. But this is not the last time that you're going to see this white TPU Air. I have 2 videos in mind where I want to use it. One is just using it on its own, and the other is a multicolor video, but that will have to wait for a little bit. And I think any of you that know why this didn't work and might know why it would work, you probably know exactly what I'm talking about and exactly what kind of printer I want to throw this at. So kind of giving some teases at a future video. I'm very excited for that.
Now that I've explained how I printed the TPU Air, let me show you how the actual shoe's printed.
Okay, so the shoe is finished, or the first shoe, I should say. So I am going to take this off the build plate, but I don't want to just rip it off because I don't want it to break before I even get a chance to wear it. So I am going to actually, I'll see you in a little bit, but I wanted to show you it off the build plate here. It is a little rough, so I am going to have to do some cleaning to it, but I knew I was going to have to do that already because this filament is very stringy. But it printed. Woo! All right, see you in a little bit. Here is the shoe. This balancing act is kind of tough, but here is the shoe on my foot. I'll get some better footage once the full pair is out because I'm here in my slippers, but it fits very well. It's
form-fitting, but not in a bad way. It's kind of difficult to explain, and I'll probably give a better summation once I actually walk in them a little bit more. But I am very happy with how they came out. And the big thing that I said about the Crocs, which are actually right there, is that I felt like I didn't have enough support, that I was kind of just standing on the ground once the TPU compressed. And I feel the opposite about these shoes, where I feel that they have a good amount of squish on them. And so I'm not just standing on the ground, but I'm also not standing on just plastic. I feel like I'm standing on air. So I'll see how these hold up. They're a little loose at the top. You can kind of see them folding in here when I step, and then when I let go, they come back up. That's because those holes right there actually are meant to be laced with actual laces. Now I'm going to try using filament so that it's all fully 3D printed, or 3D printer filament technically. But yeah, so I'm going to print a matching foot, because right now I don't have a matching foot, and we'll see. Okay, so this is the left shoe finally finished. Like the previous one, I'm not going to show any deplating because it takes a lot of effort, because this is really stuck here and I don't want to tear the foam. Also, the support removal is very rigorous and I don't want to break it on camera like I did with the right shoe. So this is going to be what you see of it now off the bed. And then I'll come back in a little bit. Well, a little bit for you, a lot of bit for me, but a little bit showing what it looks like after I clean it up, but it is looking very good. Okay, so here are the finalized shoes after quite a bit of cleanup. They are still a little rough. You can see a lot of stringing on the inside, and there's a lot of this vibration. So there's two things here having to do with the quality. One, this like vibration that you can see here. This is actually due to the printer I'm using, so the K1. As the print is, shaking back and forth, since this is a flexible material, it will shake and exacerbate these issues right here that I had with ringing. I have these on regular PLA prints, but since this is a flexible material, you can actually see as it's printing that these will flex and bow and make this issue worse. So I think if I wanted to improve this, I would either have to improve the K1 or switch printers, because that's not an issue with the filaments. I can't calibrate it out. I might be able to do some better vibration calibration, but I don't really know what to do or how to fix that myself. So I'll have to look into that for next time. You do have to be careful when ripping off the supports because they do like to stick. And I can show off on this shoe, I did lose some pieces of this shoe while I was taking off the supports. Right here, there's this line where it under extruded, and so this is a weak point. And unfortunately, the tongue of the shoe ripped off while it was printing. I think print orientation also really affects the quality, because depending on which way you have it oriented, that's where a lot of that vibration is going to be seen. Because you can see here that this side of the shoe is a lot less, it has a lot less ghosting compared to this side. This side has a lot more of the ringing. Now this isn't ringing, this is actually the design of the shoe. This is the ringing right here, and you can see it right there, right there. Ringing or ghosting, depending on what you call it. Right here, it's pretty much perfect here, but then over here, it's ringing really bad. The shoe was oriented like this on the build plate, and I believe that's because the tool head likes to park naturally to the right, and so as it stretches over here, it starts to have a little bit of trouble. Because I am maxing out the build plate on the printer. I don't think I could make this any bigger. So yeah.
Looking at the bottom, you can also see where the supports really stuck, and I ended up tearing off a portion of the shoe because I thought this was supports. So that was my fault and not the fault of the filament or the print itself. This print is very cool, very unique. However, it's very organic. So that, coupled with the organic supports, did make it a little tough to tell what was support material and what was part of the shoe, especially inside here. As you can see, those portions are very organic and really look like organic support. These are not supports. These are part of the actual shoe. But I love the way that this shoe looks, and I'm very happy with how this turned out as a whole. But you can see here, these are not finished. So let's get these laced. On the actual Maker World posting, these shoes call for regular laces, but I figured since these are 3D printed, why not take advantage of 3D printing and just use TPU as the laces. I'm not exactly sure how this is going to turn out, but I have high hopes. The color I chose is not a SirayaTech TPU. This is Inland Clear Blue, Translucent Blue, sorry, TPU, and I am going to use just the regular filament as a shoelace. I figured, why not? The one thing that I've noticed in wearing these shoes is that they are a little loose, so they definitely do need laces. And again, I think that's part of the design because these are, regular shoes. So I'm going to get these laced up, and then after that, I think it's ready for the first full test drive wearing these shoes. So let's get into it. All right, so that seems pretty good. I'm going to pull these back out, measure the distance that I cut the TPU to, and cut the second set of laces. Okay, so now both of the shoes have their laces. I'm gonna go put these on, and what do you say we go for a little walk?
So, as I walk, let's discuss my overall thoughts and conclusions. First off, a huge thanks to SirayaTech for sending me both rolls of TPU Air for this video, that being the white and the green TPU. I'm still a small channel, so them taking a chance on me really means the world. They didn't have any say in any of the thoughts I'm about to say, and everything that I am saying is going to be fully genuine. I don't normally get the chance to print with SirayaTech materials since they specialize in UV resins, and I don't even have a resin printer, and engineering filaments. Now, engineering filaments is a term that I use to categorize specifically made specialty plastics that most people don't print with. For example, PLA, PETG, TPU, ABS, and even ASA are pretty popular with color variations from many different companies. Stuff like TPU Air, fiber-filled materials, glass-filled materials are highly specialized and as such are much harder to print and require specialty hardware to print. Going into this project, I knew that TPU Air would be a challenge, but I welcomed it with open arms because I want to start tinkering with plastics now that I have much more reliable machines. While I focused on printing methods a lot more in this video, I found this material actually wasn't as challenging to print with as I had originally thought it was going to be. Despite explicit advice from SirayaTech and many other sources, I basically printed this on a stock A1, the only change being the spool holder. I'm very proud of this fact, and it gives me a ton of confidence that you, the viewer, can actually replicate what I did. And aside from the shoes in this video in particular, that's the ultimate goal of every video that I post on this channel, that being replicatability. Alright, so let's go from the filament to the shoes. I felt this project was a huge step forward in my main pursuit of finding a 3D printed shoe that can replace the traditional ones that I wear on an everyday basis. One thing I didn't highlight up until now is the foaming nature of TPU Air. TPU Air is named such because of its low density. For a specific scenario, let's just look at one shoe. If I were to print one shoe in, let's say, Polymaker Polyflex 90A, that's very specific, but the reason that I choose it is because it was used as the main filament in the previous croc video. The cost of this Polyflex shoe would be a little over 400 grams of material, meaning each shoe would cost about $16. By comparison, the TPU Air shoe weighed just over 100 grams per shoe, leading to the final cost of only $5 per shoe. This means that just on a cost comparison level, I could get about 3 TPU Air shoes for the cost of just one traditional TPU shoe. The variable hardness also means that I could experiment with what feels best for the shoe that I have, giving me much more engineering flexibility, no pun intended, for a much cheaper price. Now these are the numbers, but a shoe is meant to be worn, not calculated. So how did they feel? Well, overall I'd say they were very good. I think they feel better than the Crocs. I was a bit limited in the same way as the Crocs, since my K1's print volume is only so big. The 100% sized whaleberries are sized for a 10.5 male US shoe, and I normally wear an 11. With a bigger printer, I hope to print new shoes without this size limitation, and this by no means reflects on the designer or the filament. Sizing aside, I found the fit rather comfortable. I stated earlier that it hugged my foot, but not in a bad way. I know that's kind of a weird way to describe it, but I think it's because of the filament that I used, that being the TPU Air. Because it was lighter, it didn't rub on my feet like the Crocs did. Instead, it flexed when I walked. The design also added to this with its unique organic shape. All this being said, these shoes are not perfect. I'm a bit dissatisfied with the overall print quality. In some areas it looks really great, but in others it really suffered. I think this is due to the K1 and not the filament. I mean, I have issues with vibration on my K1 with just regular PLA, and TPU is even more sensitive to vibration. The next time I tackle printed shoes, I think I'd like to switch printers to one that has a better handle on vibration and a bigger print volume to possibly fix these issues. The final issue I had with these was totally my fault. The laces for this print did not work at all and were a complete failure. The TPU I used would not grip onto itself and I couldn't keep them tied. I think you can see that right now as I'm walking. I have to keep stopping and retying the shoes. I really would like to keep the idea of each shoe being completely 3D printed, but next time I'll need to design my own lace or possibly use a different material for the filament lace. Alright, well, thank you all very much for making it to this point in the video. I had a ton of fun making these. I hope this video was both entertaining and educational, and maybe it gave you some confidence to try printing with tougher materials yourself. Again, huge shout out to SirayaTech for sending me the TPU Air for this project. I couldn't have done it without them. As for me and future videos, this is just the beginning. While making this video, SirayaTech announced a brand new filament called, I think it's Roamer? And wait a minute, hey, those shoes look familiar. Also, while making this video, I couldn't help but share my updates with SirayaTech while I was going, and well, let's just say they were just as excited to see a follow-up video as I was. And with that, I'll catch you all in the next video. Thank you so much for watching.